Okay. There needs to be some little volume on that. Might not hurt. Yeah, can you hear me now? Yes? No? How about that? Did that do it? All right. So I'm going to cover a few more slides just so that I have something finished. I actually wrote the exam and this isn't on it, I have to confess. But I do want to finish this off. And then we'll go and we'll do review. And you can either drive it from your asking questions or I'll go down a list, whichever makes you happy. So I want to talk about the long run. The long run is a period so long that all inputs are variable. So remember our U-shaped cost curve story was I buy a factory and I write down the cost curve for the factory. It's U-shaped. Why does it curve up when quantity goes up? Because there's only so much you can make from one factory. So what's fixed? The number of factories, the number of plants. My long run story is I change the number of plants. We're going to have many different plants or factories. Each one has a U-shaped cost curve. And I'm going to take the case where they're all identical to begin with. And let's see what happens. So each firm with a U-shaped cost curve has particular fixed capital stock. In the short run, what's fixed? The capital stock. In the long run, what's variable? Everything. When do firms enter and exit? They enter when profits are positive. Now, we could spend a very long time on this because what an economist means by profits and the common usage of the word profits differ. For us, to say someone has zero profits means that they are making as much money in this activity as they would make in an average activity. So say the stock market returns 7% a year. If your company makes 7% a year, we call that zero profits. Obviously, in the business lingo, the word would really be earnings, and they would have large earnings. So for us, zero profits is you've made the same doing this that you'd make doing anything else. So if you're making more doing this than you make doing other things, then you should build more firms, right? It's a good deal. You should do it. So positive profits means better than the other things you could do. Now I'm just going to add up the supply curves from a bunch of firms. So here's the standard U-shaped cost diagram. That's the shutdown point. This is the marginal cost curve. And so everything above the minimum point of ABC along the marginal cost curve is the supply curve from one firm. If there were 4 firms, what would be the supply curve? Literally 4 times the quantity of one firm. So pick a price. Convenient price here is the least price, right? Minimum of average variable cost supply below this is 0. At this point, each firm would produce on their marginal cost curve the length of the purple arrow. There are 4 firms, so 1, 2, 3, 4 purple arrows. And that point is what 4 firms would produce if price was at the minimum of average variable cost. Do the same thing again. The next point I picked the break-even point, where profits are 0. Price equals average cost, right? So profits are quantity times price minus average cost. If P equals AC, profits are 0. Let's break even. Again, the light blue arrow is what one firm would do. Multiply by 4. 4 light blue arrows, that's what 4 firms will do. And then I do it with 2 higher prices, dark blue and red. Then connect them up as usual. That is the supply curve if there were 4 firms. I could do this again with 5 firms or 3 firms or any number of firms. And here I tried 3 firms and 2 firms. Yep. So for 2 firms, I just take 2 arrows for each price and connect them up. For 3 firms, it's 3. 4 firms, it's 4. So I can produce the short run supply curves for any number of firms. Now I put this all on one diagram. On the left is average cost, marginal cost for a typical firm. On the right is the 3 firm supply curve, S3, and I drew a demand curve. Where the demand intersects supply, you have the price. So the 3 firm supply curve is the industry supply curve, is the total supply curve. Demand curve is the demand curve, supply curve is demand, gives you price. Price is the blue line, the thick blue line, and has kind of an arrow pointing back to P. So what would happen next? What are profits? Are they positive, negative, or 0 at this price? Positive, yes. So will firms want to enter? All right, so that puts our diagram in motion. And is that the profits box? But look at it, it's well drawn. So you start out with supply equals demand, gives me P, come back on P to marginal cost. It's above average variable cost, which is somewhere down here. You needn't worry about that. Don't care whether it's going up or down over here. It's irrelevant. Right? So now I've got where price equals marginal cost. What do? I come down to the quantity, which I marked as Q star. Now to get the profits box, I have price minus average cost at that quantity. Do you see the daylight down there between the box and the average cost curve? There has to be daylight because I'm on the upward sloping part of this curve. I know that because marginal cost goes through at the bottom. So if I'm to the right of that, this thing slopes up. Right? And so if I found average cost at a point like this and I drew a straight line, I would be able to see a little sliver of light. Yeah? So that's the way the diagram really works. And that's your profits box. Price minus average cost times quantity, which is the same as price times quantity called revenue minus average cost times quantity called cost. So it's revenue minus cost exactly. So now we've reviewed that diagram in the process. I guess while we're there, we might as well finish our review of that. Can you make a quick argument for why the firm chooses quantity where price equals average cost? Quick argument for it. Standing on one foot. Yeah? Can I stand on one foot long enough? Okay. So if quantity were chosen where price was greater than marginal cost, what would happen? You'd want to make more. Why? Because you get paid price, and you only have to pay out to make the next unit marginal cost. So P minus MC positive means you can make more money by making one more unit, right? And then if I can stand on the other foot, suppose it were the other way. No, I can't stand on this foot if I don't do it long enough. Suppose it were the other way. Well, then if you made one less unit, you'd save MC, and you'd give up what you got paid, which was price. Since MC is bigger than P, you'd have more money left in your pocket, and your profits would go up. Therefore, you have to produce at the only place less where price equals marginal cost. And you should be able to spin that out because that is the most standard question anyone could ever ask you. So one of the interesting facts about PowerPoint that you would never guess is the colors aren't stable. As you move it from platform to platform, the colors change. So you see my later slides, I'll have dash lines and things that are unambiguous. But you're absolutely right. You can cross that out and write blue, or you can assume I'm colorblind. It was not a thing that I expected to be true about PowerPoint. It's a feature. All right, so the story for why firm set Q to make P equal MC is a standard story in economics, and something someone surely should ask you on an exam. What about why do you not produce when price is less than the minimum point of average variable cost? You got to tell a story for that. I'm going to write on the board. I think I would write profits equal price minus average variable cost times quantity minus fixed cost. And I would point out that profits, if you produce 0, is minus fixed cost. And if P is less than the minimum point of ABC, this is negative regardless of what quantity you choose. And so this will be less than this. So profits will be higher producing nothing than producing where price is less than average variable cost. That's what I would say if someone asked me. And those two facts together give you the supply curve. So let's go back, now that we've reviewed the U-shaped cost diagram, let's go back and see what happens. We have positive profits, and lo and behold, another firm enters, and it's magically drawn, so what happens? What are profits now? 0. That's magical, right? That's because I drew the things to make it work out that way. We don't know that one firm is the right amount all the time. But I've drawn it, so adding one more firm, profits are 0. Do any firms want to come in? No. Do any firms want to leave? No. That's long-run equilibrium. Supply equals demand. Price equals marginal cost above average variable cost, right? And profits equals 0. Those three things give you a long-run equilibrium. Now let's set it in motion a little more. Well, there's your long-run supply curve. Let's see if we can. Yeah, that's the same. Come on, do I have it? Yeah. No. I wanted to set this in motion a little further. So what would happen if I shifted demand outwards? People decide they love this product, and more of them are buying it at every price. Demand is shifted outwards. What happens? Price goes up, profits go up, firms enter, and they shift the supply curve out further until what happens? So we're right back here. It's 0 profits. So in the long run, this industry will produce any amount of output at the price equals average cost. That's what will happen in the long run as the number of firms adjust. And what I do with that, and I don't think I'm running too far behind, so I'll do it. Let's recall that the costs with a tax are more than the costs with a TDS are more than the costs without either. Right? We have that. That's something you know. Why? Because you actually have to pay the tax. It's all calibrated. You're doing the same thing. So if the costs are greater, so are the average costs. So let's draw the 3 average costs. I've just drawn them stacked up. I don't really know what they look like except one's above another. So here's the tax. Here's with the command and control, TDS, and here's the original case. Here are the 3 long-run supply curves, and here's the demand curve. In that diagram, who pays the cost of the regulation? Right? This is the cost of having a TDS. Who pays it? Consumer or producer? Think back to remember the first problem set? And you had a supply curve, and it was horizontal, and then you did something, you had a tax instead of a cost. And what happened when it was horizontal? Who paid it? Yeah, consumers pay 100% of this, do they not? Price goes up by the entire amount. So if you've got an industry that has this property that you just keep building more plants and it's competitive, and you regulate this industry, you are not going to change this industry's profits because by definition they are 0 in the long run. And so where is that money going to come from? Guess what? The only place it can come from is the consumer. It has a nice effect though, as you charge the consumer the right amount. Right? Here I've made the producer pay. Yeah, I'm going to pay the tax, but in order to stay in business, right, they have to have break even, otherwise firms will leave. So what happens? You got a long run supply curve, got an intersection with demand. Indeed, consumers paying the price, but look, the quantity's gone down quite a bit. So the good part of the polluter pays principle here is it drives down the quantity of the polluting good more than the TDS does. And there I made some reasonable use of it. I don't think I have to say more. There's a bunch of slides on grandfathering. Maybe we'll do them later, but you're now at the point where you've seen the standard stuff and a little beyond. Okay. So I can take that out of the way, and I can go find a review sheet. So I guess we start with deriving cost curves from isoquants. And we're having a review here, so it's mostly going to be on the board. If you're listening to us, you can see the review sheet or get it online, but I don't think there's anything else useful. So I think we're going to end our broadcast at this point.